Alright, this video is to go over limits 3. Okay, problem number 1. F of x is equal to sine 3x over x. Part A, compute the limit as x approaches 0. Well, if you plug in 0, you get 0 over 0, indeterminate, so you want to look for friend. So since this is 3x, you multiply top and bottom by 3. And as x approaches 0, does that also go to 0? The answer is yes. So that's friend, which goes to 1. 3 times 1, 3. B, what is the limit as x approaches pi over 2 of sine of 3x over x? Well, if you plug in 3 pi over 2, you get sine of 3 pi over 2, which is negative 1 over pi over 2. So the answer is negative 2 over pi. Remember, if you can plug in the number and get something, that's the answer. The limit as x approaches pi of sine 3x over x, well, if you plug in pi, you get 0 over pi, which is 0. And then D, what's the limit as x approaches infinity of sine 3x over x? Well, sine 3x always oscillates between negative 1 and 1, and the bottom keeps getting bigger and bigger. So again, we get the same graph again. It oscillates back and forth, but the amplitude is getting smaller and smaller, so the answer is 0. Number 2. A function is x squared minus 4 over x cubed minus 3x plus 2. You might want to have it all factored before you even start. Because when you compute limits, now the denominator, you're going to have to use synthetic division. So it looks like a x minus 1 squared times x plus 2. That's what it looks like to me. And then now we can do the limits. A, what is the limit as x approaches negative 2? Well, if you plug in negative 2, you're going to get 0 over 0. So if you cancel these out, you get what? What happens when you plug in negative 2 now? You get negative 4 over negative 2 minus 1 squared, which is 9. Negative 4 ninths. B, what's the limit as x approaches 1 from the left? Now, if you cross these out, cancel these out, look at what's left. If you plug in 1, you get negative 1 over 0. That means there's a vertical asymptote there. So if you have a vertical asymptote at x equal 1, as you approach 1 from the left, it's either going to go up to infinity or down to negative infinity. It's a 50-50 chance. So plug in a number very close to 1 on the left, like 0.999. 0.999 minus 2 is negative. 0.999 minus 1 squared is positive. Negative over positive is negative infinity. So that means the graph is going downward like that. Part C, what is the limit as x approaches 1 from the right? Well, if it's going down on this side, then on this side it has to go down as well because there's an even power there. So that one would also have to be negative infinity. And then D, what's the limit as x approaches infinity? Well, as the graph is going out to the right, it's going to get closer to whatever the horizontal asymptote is. Well, if the degree of the bottom is bigger than the top, then the asymptote is y equals 0. So that's the answer there. Number 3, piecewise function. This looks like the one on the quiz, except different. Okay, so you got a horizontal line, then you got a semicircle, and then you got a line. Now, if you want to graph this, you can. Yeah, let's just graph it for funsies. So when x is less than negative 1, then you get the line y equal 1. So, whoa! And then this is the semicircle between negative 1 and 1. Whoop! And then this is a line. There, that's what the graph looks like. So, compute A, limit of this function as x approaches negative 1. Well, here's negative 1 right here. Coming from the left and coming from the right, is it going toward the same point? And the answer is no, so the limit does not exist. B, what is the limit of this function as x approaches 1, I'm assuming? Yep. So here's 1 right here, coming from the left and the right. Is it going toward the same point? Yep. And what is the y-coordinate of that point? 0. So again, if you have the graph in front of your face, easy to compute limits. Number 4, let's see if we can squeeze it in over here. We have a piecewise function. Woo! Root 5x plus 1 minus root x squared plus x plus 4 all over x minus 3 when x is not equal to 3. That's because there's probably a removable discontinuity there. And then it's equal to k when x is 3. So we had a problem like this before, but here, let me explain what's going on. This graph has a removable discontinuity probably at x equal 3. So to make this function continuous, don't you have to fill in this puka right here? Yeah, so that's what this number should be. This number should be the y-coordinate of that puka so that it fills it in and it becomes continuous. So how do I find the y-coordinate of that? Yeah, you take the limit as x approaches 3 of that thing right there. You can see it's going to the same point from the left and the right. And we want the y-coordinate of that point. So what is the limit as x approaches 3 of this thing right here? Well, when you plug in 3, you get 4 minus 4 over 3 minus 3. That's 0 over 0. So what do you do when you have a radical? You multiply top and bottom by the conjugate of the radical expression. So we're going to multiply top and bottom by root 5x plus 1 plus root. So this is just doing algebra here. This problem's not difficult. X squared plus x plus 4. Now if you multiply out the numerator, you're going to get 5x plus 1. Okay, don't pay any attention to this 3 here. Okay, 5x plus 1 minus, and please put the parentheses there, x plus 4. What happens when you distributize that minus sign? You're going to get negative x squared plus 4x minus 3. Factor out the minus sign, x squared minus 4x plus 3. That can be factored, so negative x minus 1, x minus 3. Now, is that good? Yep, because that x minus 3 cancels that x minus 3. Now, can I plug in 3 and get something? Yes, negative 2 over, and what happens when you plug in 3 here? You get 4 plus 4, which is 8. And so that's negative 1/4. So you have to make k equal to negative 1/4 to fill in the puka right there. Because the y-coordinate of that point is negative 1/4. Yeah, which in other words, it should be below the y-axis, x-axis. All right. 5, we had a problem like this before. That's why it's on the practice test. X cubed, negative 1 is literally 2, and bx plus a when x is greater than 2. So if we want this function to be continuous, this first piece and the second piece have to meet when x is negative 1. So it's kind of like here. Here's negative 1 and here's 2. The first piece and the second piece, whatever it is, they have to meet there. So if you plug in negative 1 for x here and negative 1 for x there, you have to get the same value. So plugging in negative 1 there, you get negative a plus b. And if you plug in negative 1 there, you get negative 1. And then the same thing with the second and third pieces. They have to meet, they actually have to touch when x is 2. So if you plug in 2 for x here and 2 for x there, you got to get the same number. So plug in 2 for x there, you get a. Plug in 2 for x there, you get 2b plus a. 2 equations, 2 variables. I think I can let you guys solve that. In fact, look, if you just add the equations, the a's disappear. Come on! Now, number 6, now you have a whole truckload of limits to compute. This is just like the test. So, 6a, what is the limit as x approaches 0? 4 plus x cubed minus 4 cubed all over x. Well, the first thing you do is plug in the number. 0 over 0, indeterminate. So in this problem, it looks like we want to simplify it. So do we remember how to cube? Cube a plus b cubed? Yeah, a cubed plus 3a squared b. So what would that be? 3a squared b. 48x plus 3ab squared, 12x squared, plus b cubed minus 4 cubed, which is 64. But it really doesn't matter because they cancel out. Can I factor out an x in the, yep, you can. You get 48 plus 12x plus x squared. The x's cancel out. Now can I plug in 0 for x? Yes, if you plug in 0 for x, you get 48 plus 0 plus 0. That's 48. B, limit x approaches 5 from the left of x squared minus 25 over the absolute value of x minus 5. Now, some of you might be thinking, hey, there's a vertical asymptote there, but there's not. You need to write a piecewise function for this. So the piecewise function is if x is greater than 5 and x is less than 5. So if x is greater than 5, remember, how does absolute value work? If the inside is positive, you leave it alone. If the inside is negative, you negate it. So if x is greater than 5, the inside is positive, so you just leave it alone. So you get x squared minus 25 over x minus 5. And then as x is less than 5, the inside is negative, so you negate it, and you get x squared minus 25 over negative x minus 5. But do you notice that this can be simplified? This is x plus 5 times x minus 5. The x minus 5's cancel, and so you just have x plus 5 when x is greater than 5. And negative x plus 5 when x is less than 5. So if I'm taking the limit as x approaches 5 from the left, which of these two pieces am I going to use? That's right, this one, because x is less than 5. So all you have to do is plug in 5 right there, negative 10, boom. C, limit x approaches infinity, tan inverse 4 minus x squared over 4 plus x squared. Now, just look at the thing in the parentheses. What's the limit as x approaches infinity of that? Well, if the degree of the top and the bottom are the same, you look at the coefficients, negative 1. So therefore, the whole thing gets closer and closer to tan inverse of negative 1, negative pi over 4. How come it's not 3 pi over 4? Because it's not in the range. You got to know the range. D, limit x approaches 0, 1 minus cosine 3x over x squared. Well, if you plug in 0, you get 0 over 0. So there's two things you can do. You can multiply top and bottom by 1 plus cosine 3x, which is the conjugate. Or you can use power series. I would prefer to use power series on this one. So what's the power series of cosine box? 1 minus box squared all over 2 factorial plus box to the 4 over 4 factorial minus dot 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 all over x squared. What happens when you distributize this minus sign? This becomes minus, this becomes plus, this becomes minus. These ones cancel out, and then if you lift and separate here, you get this over that. I mean this over x squared. The x squareds cancel out, and what's going to be left? 9 over 2 factorial. And then starting from here, you're going to have an x squared and x to the 4th, x to the 6th. When you plug in 0, those all go to 0. So the only thing left is that very first term, which is 9/2. E, what's the limit as x approaches infinity? Cosine inverse, natural log x over e to the x. Well, if you look at the thing in the parentheses, both top and the bottom both go to infinity, so n to the n fepal. This is logarithm, that's exponential. Exponential goes faster than logarithm, that goes to 0. So the whole thing gets closer and closer to cosine inverse 0, which is pi over 2. F. Okay, so this goes to 1, but then that goes to infinity, so this is an indeterminate case. Anyway, you guys should recognize this one. This one has something to do with E. So the first thing you do is, holy, right? Make sure you put the negative in the exponent. Lift and separate. So that's 1 plus negative 1 over x, right? Because we need the plus sign to be there. To the x to the negative 1. Therefore, the thing in the brackets gets closer and closer to e to the negative 1, right? Because that's going to be the power of x. So what's e to the negative 1 to the negative 1? E. G. Oh, we're going to need room. Let's go over here. Limit x approaches 0, 1 over the square root of 4 plus x, all over 1 over the square root of 4 minus all over x. Well, if you plug in 0 for x, you get 0 over 0. So we need to simplify this. So what do you do when you subtract fractions? You make a least common denominator. Okay, and then, so this is 2, right? Square root of 4 is 2. So 2 minus the square root of 4 plus x, and when you divide by x, the x goes down here. So what do? Multiply by conjugate, because I have a radical here. So 2 plus root 4 plus x, 2 plus root 4 plus x. So what happens when I multiply that out? You're going to have 4 minus 4 plus x. Please put the parentheses there. All over 2 root 4 plus x times 2 plus root 4 plus x. Distribute this minus sign. The 4's cancel out. This x goes into that and you get a negative 1 left. Now can I plug in 0 for x and get something? Yes. Negative 1 over 2 times root 4, which is 2, times 2 plus root 4, which is 4. So negative 116. Bam. H. Limit x approaches infinity, secant inverse root 2x squared plus 3x plus 4 all over x squared plus 2x plus 3. Now just look at this thing right there. If the degree of the top is the same as the bottom, right, as x approaches infinity, you just look at the coefficients, 2 over 1. This gets closer and closer to 2. Therefore, the whole thing gets closer and closer to secant inverse of radical 2, which of course is pi over 4. I limit x approaches 0, x cosecant pi x. Well, if you plug in 0, you get 0, but then that goes to infinity. So this is the 0 times infinity indeterminate case. So what do? Look for friend. Because isn't cosecant the same thing as 1 over sine? But we need to hooly this because remember, you need sine box over box. So you hooly. Now, is that friend yet? No, because you need sine box over box. See how the box is pi x? So you need to multiply top and bottom by pi to get the pi x there. So now, here's the question. I have sine box over box, but is the box going to 0? As x gets closer and closer to 0, does pi x also get closer and closer to 0? The answer is yes. So this is friend. It goes to 1. Therefore, the whole thing gets closer to pi to the negative 1, which is 1 over pi. J. What's the limit as x approaches 1 from the left? X squared minus 1 over x cubed minus 3x plus 2. Well, what happens when you plug in 1? You get 0 over 0, indeterminate. So we need to simplify this. Now, I think I put this 1 from the left just to try and throw you off the scent. You guys are not going to fall for that, right? Now, if you factor the denominator, I believe that's x minus 1 squared times x plus 2. I think we had that before. Oh. 1 from the left, 0 over 0. Okay, so now I can cancel this x minus 1 with one of those x minus 1s. Now what happens when I plug in 1 for x? You get 2 over 0. Ah, that means there's a vertical asymptote there, right? Non-zero over 0. So there, no, so I was thinking I was throwing you off, but I'm not. So approaching 1 from the left, it's either going to be infinity or negative infinity. Let's just put that there, 50-50 chance. So plug in a number very close to 1 on the left, like 0.999. What is 0.999 plus 1? Positive. What is 0.999 minus 1? Negative. What is 0.999 plus 2? Positive. So what is positive over negative times positive? Negative. So the answer is negative infinity. So it's very important to plug in the number. 0 over 0 indeterminate, but then when I cancel these out, now I get 2 over 0. Vertical asymptote. Okay. Hey, we had this problem on the homework. Square root of x squared minus 4x minus x. You guys remember what we did in the homework? We completed the square. Now the only reason you can do that is because x is approaching infinity. If x is approaching any other number, you can't do that. Because when x is really large, that plus 4 is insignificant. So that's why you can complete the square. Now, why do you want to complete the square? Because that's x minus 2 quantity squared. Right? And what's the square root of x minus 2 quantity squared? Absolute value of x minus 2. But since x is approaching infinity, that means the inside is positive, so you just leave it alone. and then these cancel out, and you get negative 2. So again, when you see absolute value, you got to make a piecewise function. Well, you don't have to. You can just get the problem wrong. L. Okay, this is the step function, the greatest integer function. X approaches 2 from the left of minus x. Okay, the easiest thing to do here is plug in a number very close to 2 on the left. This only works when you have this greatest integer function thing. So plug in like 1.999. What is the greatest integer of 1.9999? 1 minus 1.99999. What do you get? Negative 0.99999, which is very close to negative 1. M. What is the limit as x approaches 0 from the right, cosine of 1 over x? Well, as x approaches 0 from the right, what happens with this? What is 1 over like 0.00000001? It's a super huge positive number. So this is going to infinity. So this problem is the same thing as this problem. The limit as x approaches infinity of cosine x. Both of these problems are exactly the same because x is approaching infinity and cosine x. Just like over here, cosine box, but the box is going to infinity. It's the same problem. Do you know how to do this problem? Yeah, look at the graph. What does cosine look like? As the graph is going off to the right, is it getting closer and closer to anything? No, the limit does not exist. Yes, and you can write D and E tomorrow, so that's no problem. Okay, we're almost done. N, limit x approaches 0, 1 minus e to the x over x. Well, if you plug in 0, you get 0 over 0, indeterminate, so you got to come up with something, in this case, power series. Don't worry, tomorrow on the test, there's a whole section just on power series. It's going to tell you, use power series to compute these limits, so you know that you got to use power series for those. You don't have to wonder. So what's the power series for e to the x? 1 plus x squared over 2 factorial plus dot dot dot. When you distribute this minus sign, make sure you distribute now, because the problems are going to be all or nothing. The 1's cancel out. And then now lift and separate. What's negative x over x? Negative 1. And then starting from this term, they all have x's in it, so everything just goes to 0. So that's the answer. The first term is the answer. Okay, okay, we need room for this. I seem to remember doing this problem in one of the classes. Limit x approaches 0, cosine of pi over 6 plus x minus cosine of pi over 6 all over x. Hey, this kind of looks like the derivative. Yeah, but I didn't teach you this yet, so we're going to have to do this the long way. Now, in order to do this problem, you have to know friend and acquaintance. Okay, so what happens when you plug in 0 for x? You get 0 over 0. What a surprise. So what do? Well, you got to expand this. Cosine of gorilla plus banana is cosine of the first, cosine of the second, minus sine of the first, sine of the second, minus cosine of pi over 6, all over x. Now we need to look for friend and acquaintance. Well, you're going to lift and separate. So what do we have here? Look, sine x over x. So look at the second term. Negative sine pi over 6. And then you have sine x over x. There she blows. There's friend. And then if you factor out a negative cosine pi over 6 from the first and the third term, you're going to get 1 minus cosine x all over x. Hey, that's acquaintance. Right? So, friend goes to 1, acquaintance goes to 0. So, what's left? Negative sine pi over 6, which of course this is 1/2, right? And this of course is root 3 over 2, but it doesn't matter because you're multiplying it by 0. So what do you have? Negative half is your answer. P. Hey, this is like the 4th time we've done this problem. Okay, as x approaches infinity, that goes to infinity, that goes to 0. Sine of 0 is 0, so this is the infinity times 0 indeterminate case. What do? Look for friend. Well, When you have an x in the numerator, isn't that the same thing as a 1 over x in the denominator? So I have signed box over box, but the question is that friend? Is the box going to 0? If the box is going to 0, that's friend. As x approaches infinity, what happens to that? It gets closer and closer to 0. So this is friend. That is 1. Q, limit x approaches 2, square root of 7 plus x minus 3, all over x cubed minus 8. Now what happens when you plug in 2? You get 0 over 0, indeterminate. So what were you taught? Multiply top and bottom by the conjugate of the radical expression. Okay, so you got limit, x approaches 2. So multiply out the top, what are you going to get? 7 plus x minus 9, which is x minus 2. But then that's no problem because this can be factored, right? Difference of cubes. And what happens if you can't remember the difference of cubes? Do synthetic division. See, look, x minus 2's cancel out. Now can I plug in 2 and get something? Yes. What? 4 plus 4 plus 4 is 12. And then what is this? 3 plus 3 is 6. 1 over 72. Woo! And then r. Limit x approaches 0 from the left. Cosine x over x. Well, if I plug in 0, you get 1 over 0. Non-zero over 0 means there's a vertical asymptote there. So as you approach 0 from the left, the answer is either going to be infinity or negative infinity. How do you figure out which one it is? Plug in a number very close to 0 on the left, like negative 0.0001. What is the cosine of negative 0.0001? Look at the unit circle. Negative 0.0001 is like this very tiny angle in the fourth quadrant. What is cosine in the fourth quadrant? Positive. And the denominator, negative 0.00 is negative, so what's positive over negative? Negative infinity. So that's why it's very important to plug in the number. You need to know the difference between 0 over 0 and non-zero over 0. All right, goodbye.